You flip a switch, light floods the room. Simple, right? You've done it 10,000 times. But have you ever stopped, truly stopped, to ask yourself what just happened? I mean, really happened. Not the superficial answer, not electricity flowed. I want you to dig deeper. What moved? Where did it come from? And why on earth does flipping a little plastic toggle cause photons to shoot out of a bulb across the room? Most people can't answer this. They'll say something about power, about current, about energy traveling through wires. But here's what bothers me about those answers. They're just words stacked on top of mystery. You're not explaining electricity. You're just giving the mystery a different name. The reality, what we call electricity, is so fundamentally bizarre, so counterintuitive, that if you actually understood what was happening every time you charged your phone, you'd probably never look at the physical world the same way again. We've built our entire modern civilization on top of a phenomenon that violates almost everything your common sense tells you about how objects interact. Let me prove it to you with something you can do right now. Grab some plastic, a pen, a ruler, whatever. Rub it vigorously on your shirt or your hair. Now hold it near some tiny scraps of paper without touching them. Watch what happens. The paper jumps, it literally leaps through empty air toward the plastic. Pause, right there. Let that sink in. You rub plastic against fabric. That's all. No power plant, no battery, no sophisticated technology. Just friction. And now that plastic can manipulate matter from a distance. It can reach across the void and yank on other objects without making contact. In your everyday experience, this should be impossible. Things only interact when they touch. You want to move a chair? You touch it. You want to pick up your coffee? You touch it. The world operates on contact, on mechanical pushing and shoving. Yet here's a piece of plastic not touching anything, exerting influence through apparently empty space. Now, most people have been taught a label for this. Static electricity. They learned about it in school, saw some demonstration with balloons and hair, maybe giggled at how silly it looked, and moved on. It became a party trick, a minor curiosity, completely irrelevant to anything important, but that dismissal is catastrophic. You're not looking at a parlor trick. You're staring directly at one of the four fundamental forces governing our entire universe. You're witnessing the same force that binds every atom in your body together, the force that makes all of chemistry possible, the force that allows neurons to transmit signals through your brain right now as you process these words. This is the electromagnetic force demonstrating what it does best, acting across distance. And we treat it like it's boring. Here's what actually happened when you rubbed that plastic. You didn't create anything, you just moved some electrons around. Friction scraped electrons off one surface and deposited them onto another. Maybe a few trillion extra electrons ended up on that plastic. Sounds like a lot, but in the grand scheme it's almost nothing. But here's where your brain needs to break a little. Those electrons hate each other. Not metaphorically. They repel each other with a force so stupendously large that human language barely has the capacity to describe it. Let me try anyway. Take two electrons. Just two. Place them 1 centimeter apart. The electromagnetic force pushing them apart is roughly 100 million trillion times stronger than the gravitational force trying to pull them together. That's a 1 with 42 zeros after it. Gravity, by comparison, is so pathetically weak that for electrons it might as well not exist at all. So here's the question that should be making your head spin. If electromagnetic forces are that incomprehensibly powerful, why doesn't everything just explode? Why isn't matter constantly tearing itself into confetti? The answer is almost too elegant. Perfect balance. Think about atomic structure. You've got a nucleus with protons, positive charges. You've got electrons orbiting around negative charges. And here's the beautiful part. Like charges repel, opposite charges attract, and the magnitudes are identical. Every positive is surrounded by negatives. Every negative is surrounded by positives. The monstrous repulsive forces are exactly cancelled by equally monstrous attractive forces. Everything is neutral, or rather almost everything, because those forces are so absurdly strong. Even the tiniest imbalance, moving just one electron out of every trillion, creates an effect you can physically feel. That's what happened with your plastic. A microscopic excess of charge, and suddenly paper is jumping around. This completely reframes what matter actually is. Pick something up, a book, a phone, anything. What are you feeling? You think it's solidity, right? Physical substance pressing against your skin? Wrong. Dead wrong. What you're feeling is electromagnetic repulsion. The electrons in your hand are screaming away from the electrons in the object. They refuse to occupy the same space. The reason you can't push your hand through a solid object isn't because matter is solid in some intuitive sense. It's because the electromagnetic forces are so powerful that electrons simply will not overlap. And here's the kicker. Your hand never actually touches the object. Ever. There's always a gap, an infinitesimally small gap between the atoms in your hand and the atoms in the object. You're not feeling contact. You're feeling electromagnetic force pushing back across that gap. Every single thing you've ever touched in your life, you didn't. You felt electromagnetic repulsion from a distance. Every sensation of pressure, of texture, of resistance, all of it is electromagnetic forces acting through space. The plastic wrap experiment isn't showing you something unusual. It's showing you what's happening all the time, just at a scale where you can finally notice it. Now let's talk about what happens inside your walls. You've got copper wire running from an outlet to a lamp. You flip the switch instantly, and I mean instantly, the lamp turns on. What moved? The obvious answer is that electricity flows like water. Electrons enter at one end, travel the length of the wire, exit at the other end, and boom, light. That answer is completely, utterly wrong. Electrons in a wire move at roughly 1 millimeter per second. That's slower than a slug. At that speed, for an electron to travel from the outlet across your room to the lamp would take something like 40 minutes. But the lamp doesn't turn on in 40 minutes. It turns on immediately. So what's actually happening? Here's the key insight. The wire is already packed with electrons. Copper has loads of free electrons just sitting there, waiting. When you close the switch, you create a voltage, a pressure difference. That pressure pushes on the electrons at one end. But because electrons repel each other, that push immediately gets transmitted. The first electron pushes the second, which pushes the third, which pushes the fourth. It's like a packed train car full of people. If you shove the person at one end, the person at the far end feels it almost instantly. Not because the first person walked down the car, but because the push propagated through the crowd. The electromagnetic push travels through the wire at nearly the speed of light. Individual electrons barely move, but the influence spreads instantly. That's the genius of electricity. You can create a push here, and something responds there immediately across enormous distances. But where's that push coming from originally? Trace it backward. Your lamp connects to your wall. Your wall connects to power lines. Those power lines stretch for miles, maybe 100 miles back to a power plant. And at that power plant, something massive is spinning, a turbine, weighing multiple tons, rotating thousands of times per minute. And that spinning motion happening potentially hundreds of miles away is what's making your lamp glow right now. How is that possible? The answer is magnetism. But here's what they don't tell you in school. Electricity and magnetism aren't two different things. They're two faces of the same phenomenon. The electromagnetic force, moving electric charges, create magnetic fields. Changing magnetic fields create electric currents. They're inseparable. Here's how a power generator works. You spin copper wire through a magnetic field. The magnetic field exerts force on the electrons in that copper, pushing them, creating flow. That's current. You've turned motion into electricity using magnets and metal. Run the process backward and you get a motor. Push electricity through copper wire sitting in a magnetic field. The field shoves the electrons, the wire moves, electricity becomes motion. Same principle, reverse direction. This should sound impossible. You're telling me I can move metal at location A and metal at location B connected by nothing but thin wire will move in response? Yes. You're telling me spinning a magnet near copper generates a force that propagates through hundreds of miles of cable and makes things happen elsewhere? Yes. And we do this billions of times per day without thinking about it. Water falls over a dam. Turbines spin. Copper rotates through magnetic fields. Electrons get pushed. That push races through miles of wire at light speed. It reaches your house, flows through a motor, and your ceiling fan starts turning. Water falling in one place makes metal spin in another place, miles away, connected by nothing but wire and ultimate forces. That's not normal. That's astonishing. You don't even need permanent magnets. Take a coil of copper wire. Run current through it. The moving charges create their own magnetic field. Move that coil near another coil. The changing field induces current in the second coil even though they're not touching. That's a transformer. That's how we move power across the grid. Just copper coils talking to each other through electromagnetic fields. Now here's where this gets genuinely mind-bending. I said earlier that every force you feel is electromagnetic. Every push, every pull, every sensation. Think about what that means. The normal forces, the mechanical ones you experience daily, aren't actually fundamental. They're consequences of electromagnetism. Electromagnetic force is the bedrock reality. Everything else is downstream. When you push a door open, you're creating electromagnetic repulsion between electrons in your hand and electrons in the door. When you stand on the ground, you're suspended by electromagnetic repulsion between electrons in your feet and electrons in the floor. When light enters your eyeballs, you're detecting oscillating electromagnetic fields causing electrons in your retina to dance. Chemistry? That's electromagnetic forces between electrons in different atoms. Heat? That's atoms vibrating because electromagnetic forces hold them in specific arrangements. Biology? That's chemistry, which is electromagnetic, your entire sensory experience. Everything you see, touch, hear, taste, feel is electromagnetic interactions translated into perception. And here's the deepest cut. You can't reduce the electromagnetic force to anything simpler. You can't say it's like a spring or it's like a rope, because springs and ropes are made of electromagnetic forces. Electromagnetism is fundamental. It's one of the four basic forces of nature. You have to accept it as a brute fact and then build everything else on top. That's uncomfortable because electromagnetic force acts at a distance, and that violates every intuition evolution gave you. Your ancestors needed to understand contact forces, hitting things with rocks, pushing objects, grabbing food. But contact is a lie. There is no contact. There's only electromagnetic force acting across tiny gaps. To truly understand electricity, you have to completely rebuild your model of reality. You have to accept that the universe is made of fields pervading all of space. Charged particles push and pull across those fields. Action at a distance isn't weird, it's the rule. So when you flip a light switch, here's the actual story. You close a circuit, electrons throughout the entire wire start moving slowly, about a millimeter per second. At a power plant somewhere, a turbine spins. Magnets rotate near copper coils. The changing magnetic field pushes electrons. Those electrons push their neighbors. The push propagates at near light speed through hundreds of miles of wire. The signal reaches your house. Electrons flow through a thin tungsten filament in your bulb. That filament resists the flow. It's difficult for electrons to squeeze through. Resistance generates heat. The filament gets hot enough to glow incandescent. Electromagnetic waves radiate outward. Some hit your retina. The oscillating fields cause electrons there to move. Chemical reactions trigger. Signals race through your neurons. Your brain interprets light. Every single step, electromagnetic. The turbine spinning is electromagnetic motors. The signal traveling is electromagnetic repulsion propagating. The resistance is electromagnetic forces. The light is electromagnetic waves. Your vision is electromagnetic detection. 2 centuries ago, none of this existed. Then humans discovered these forces. We figured out the rules. We built machines to generate, transmit, and use electromagnetic forces. And in doing so, we transformed civilization. We created instant communication, telegraph, telephone, radio, internet, all electromagnetic. We created artificial light, vanishing darkness. We created motors, replacing muscle with electromagnetic force. We created computers, billions of switches manipulating electromagnetic forces to process information. Every single aspect of modern life runs on electricity, and it's all based on one insight. There's a fundamental force acting across distance, and if you learn its rules, you can do things that would look like sorcery to anyone from the 1700s. So what is electricity really? It's not a substance. It's not a fluid flowing through pipes. Electricity is our name for the deliberate manipulation of electromagnetic force to perform useful work. But more than that, electricity is proof that reality isn't what your senses suggest. The world seems mechanical, solid objects bumping into each other, but that's illusion. Reality is fields and forces, particles influencing each other across empty space. When plastic attracts paper, you're seeing the force that enables chemistry. When you turn on a light, you're commanding fields that permeate existence. When you understand this, truly understand, everything shifts. You realize the world is electric, forces act at a distance, solid matter is just balanced repulsion and attraction, exquisitely tuned, and humans figured this out. We discovered these forces, we tamed them, we built a civilization on electromagnetic foundations. That might be the greatest intellectual achievement of our species. Next time you flip a switch, remember, you're not just turning on a light, you're manipulating fundamental forces. You're making electrons push each other across cities. You're converting motion to fields and back to motion. You're wielding power over nature itself. That's what electricity really is. Not convenience. Not commodity. A window into the fundamental nature of reality and evidence that humans can comprehend and control that reality. That's the truth about electricity. Not comfort. Truth.